Okay, students. In yesterday's class, we are discussing Lee chart layer principle applications. So one application is over. The second application we are discussing, that is synthesis of sulfur trioxide. We have to discuss factors affecting on sulfur trioxide. We are discussing. So this is a synthesis of SO3 we are discussing. Okay, synthesis of SO3 we are discussing. So chemical equilibrium you have to know. Equilibrium reaction you have to know, that is SO2 gas plus O2 gas gives rise to 2SO3 gas. Okay, this is equilibrium reaction, students. So it is a forward reaction. It is a backward reaction. Okay, here if you take 2, then 2 moles of SO2 reacts with 1 mole of O2 gives rise to 2 moles of SO3. Here delta H equal to minus 189 kilojoules per mole. This is the reaction. Now we are discussing factors, influencing factors on synthesis of sulfur trioxide. Factors. So first one is effect of concentration. Okay, it is the first one. So high concentration favors forward reaction. Increase SO2 concentration of SO2 and O2, which forms sulfur trioxide. Equilibrium position shifts forward direction. Equilibrium reaction shifts forward direction. So sulfur trioxide is formed. So by continuous removal of sulfur trioxide, forward reaction takes place. So what I mean to say, high concentration, increase in concentration of SO2 and O2, which form sulfur trioxide. So increase in concentration of SO2 and O2, which form sulfur trioxide. Okay, see here, form SO3. So high concentration is favorable for the formation of sulfur trioxide. High concentration is favors formation of SO3. Okay, so this is effect of concentration. Next factor, second one, effect of pressure. effect of pressure. See here, 2 plus 1, 3 volumes of reactants. 2 plus 1 gives rise to 3 volumes of reactants. Next, 2 volumes of products. 2 volumes of products. So here delta n is not equal to 0. Then pressure shows effect on this reaction. So if you increase concentration, so equilibrium position shifts decreasing volume side. So decreasing volume side means product side. So high pressure is favorable for the formation of sulfur trioxide. But if you used high pressure, then the tower used in the synthesis of SO3 is damaged. The tower used in the synthesis of SO3 is damaged. So we are not going to use high pressure. The pressure 1.5 to 1.7 atmospheres is favors for the formation of SO3. Pressure 1.5 to 1.7 atmospheres is favors formation of SO3. Formation of SO3. Understand? This is effect of pressure. Next, effect of temperature. Next we are going to discuss effect of temperature. Effect of temperature. So here amount of energy is released. Released means exothermic reaction. So it is exothermic reaction. Exothermic reaction is a low temperature is favorable. See, low temperature is favors formation of SO3. Due to exothermic reaction, low temperature is favors for the formation of SO3. So optimum temperature 673 kelvins is used. So 673 kelvins is favors. Okay. Then effect of catalyst. See here, catalyst does not show effect on the chemical equilibrium reaction. See here, it is exothermic reaction. It is a slow reaction. Due to exothermic reaction, it is a slow reaction. To speed up the reaction, we have to use a catalyst. It is a slow reaction. To speed up this reaction, V2O5 catalyst is used to speed up this reaction. V2O5 catalyst is used. Okay, so this is effect of catalyst, effect of temperature, and equilibrium reaction, effect of concentration, effect of pressure. So optimum conditions, you have to know optimum conditions. Optimum conditions, what are optimum conditions? Means pressure equal to 1.5 to 1.7 atmospheres, temperature equal to 673 kelvins. Next, catalyst equal to V2O5. Then high concentration and high pressure favors for the formation of SO3. High concentration, high concentration, high pressure favors formation of SO3. Okay, see here, high concentration and high pressure favors formation of SO3. So this is the second application. This is a second application of Le-Chatelier principle. First one is the preparation of ammonia by Haber's process, and second one is the preparation of sulfur trioxide by contact process. These two applications. Le-Chatelier principle, application 1, application 2, very important. Very important. Okay. So this is briefly chemical equilibrium. This is briefly chemical equilibrium. So in this chapter, one more chapter is there, acids, bases. These two chapters we have to discuss in this 7th chapter. Okay, so one more chapter I am going to start, that is acids, bases. Next, we are going to discuss acids, bases. So in this chapter, first of all, you know what is an acid and what is an base. First of all, you know. So for knowing acid, what is an acid, what is an base, the need is arise to discuss Arrhenius acid base theory. The man Arrhenius given first encountered explanation about Arrhenius acid base theory. So here we are going to discuss first what is acid. So Arrhenius acid base theory we have to discuss. Arrhenius Arrhenius acid base theory. Okay. According to Arrhenius, you have to know first what is an acid. What is acid means? The chemical substance which dissolved in water, the chemical substance which gives H plus ions in water is called acid. The chemical substance which gives H plus ions in water is called acid. The chemical substance which gives H plus in water. The chemical substance which gives H plus in water is called acid. For example, HCl, H2SO4, HNO3, all these are called acids. Next you have to know base. So the chemical substance which gives OH minus ions in water. The chemical substance which gives OH minus ions in water is called base. The chemical substance which gives OH minus in water is called base. For example, sodium hydroxide, KOH, CaOH taken twice. All these are bases according to Arrhenius acid base theory. Next you have to know neutralization. Neutralization. Acid on combines with a base which gives salt plus water is called neutralization. Acid on combines with water which gives salt plus water is called neutralization. Acid plus base gives rise to salt plus water. For example, HCl plus NaOH gives rise to NaCl plus H2O. It is acid, it is a base, it is a salt, it is a water. It is a neutralization reaction. This is Arrhenius acid base theory. Okay. Discussion is over about Arrhenius acid base theory. Next, some substances do not giving H plus ions in the water even though they are having acidic nature. What about that substances means Arrhenius could not explain. So for knowing that type of substances, the need is arise to discuss one more acid base theory, that is nothing but Bronsted acid base theory. Bronsted acid base theory. So here it is a very important Bronsted acid base theory. So Bronsted acid base theory. So what is the Bronsted acid base theory? According to Bronsted acid base theory, what is an acid, what is an base? You have to know first. So first you know acid. What is an acid according to Bronsted acid base theory means the substance which give proton, means proton donor is called acid simply. The substance which donate proton is called acid, or proton donor is called acid. Proton H plus is called proton donor. Proton donor is called acid simply. For example, HCl, it is a proton donor. H3PO4, it is a proton donor. H2SO4, it is a proton donor. All these are acids according to Bronsted acid base theory. Next you have to know base. See, proton donor is called base means opposite to that is called proton donor is called acid means opposite to that is called base means proton acceptor. Proton H plus acceptor. Proton acceptor is called base. For example, Cl minus, next HSO4 minus, next HCO3 minus, all these are proton acceptors. Proton acceptors. Then you have to know a neutralization reaction. Neutralization reaction. See here, NH3 plus H2O gives rise to NH4 plus OH minus. It is a base, it is a acid, it is a conjugate acid, it is a conjugate base, it is a base, it is a acid, it is a conjugate acid, it is conjugate base. See here, from NH3 to here H plus gain, H plus gain. See, from H2O to here H plus loss. Okay. So these two pairs are differ by one proton, is called conjugate acid base pair. Conjugate acid base pair. So it is neutralization reaction according to Bronsted acid base theory. Base and combining with the acid which gives rise to one proton transfer NH4 plus and OH minus. Here you have to know conjugate acid base pair. So what is a conjugate acid base pair means? The acid base pair which differ by a proton are called conjugate acid base pair. So for example, NH3 to NH4 plus, what is the difference? One proton. Okay. So here H2O to H3O plus, what is the difference? One proton. So these two pairs differ by a proton is called acid base pair. Acid base pair. So here what is the difference? H plus. So here H plus gained, sorry, OH minus here. Here OH minus. So here what is the difference? H plus. Here what is the difference? H plus. It is a loss, it is a gain. Whatever it may be, loss or gain, whatever it may be. So here it is nothing but a base, it is nothing but a conjugate acid. It is nothing but a acid, it is nothing but a conjugate base. Understand? The acid base pair which differ by a proton is called conjugate acid base pair. So this is Bronsted acid base theory. It is very important for 4 marks. It is very important for 4 marks. Okay. So here it is very important. What is an acid according to Bronsted acid base theory? What is an base according to Bronsted acid base theory? What is a neutralization according to this theory? And conjugate acid base pair. The acid base pair which differ by a proton, which differ by a differ by a proton, which differ by a proton is called conjugate acid base pair. Okay. So this is today's acids and bases introduction. So some more topics we are going to discuss in the next class. Okay.